In one of the most remarkable scientific discoveries in recent years, astronomers have revealed what could be the first ever volcanic exomoon, an alien moon, located light years away from Earth, constantly undergoing intense volcanic activity. This is no ordinary moon. Its surface is perpetually reshaped by violent eruptions, spewing lava, ash, and gases into the vacuum of space. Far from the familiar calm moons of our solar system, this exomoon represents a dynamic and chaotic world where geological forces are constantly at play. This volcanic exomoon orbits a massive gas giant, a planet far larger and more massive than anything in our solar system. The parent planet's sheer size exerts immense tidal forces on its moon, which causes intense heating beneath the moon's surface, leading to constant volcanic eruptions. The moon is caught in a process known as tidal heating, where the gravitational interaction between the moon and its parent planet creates friction inside the moon. This friction generates heat, which is released as volcanic activity, much like the way Jupiter's moon Io experiences constant volcanic eruptions due to its interaction with Jupiter's immense gravity. However, the volcanic exomoon discovered recently is even more extreme, driven by the powerful gravitational forces of its giant parent planet. What makes this discovery so extraordinary is that the volcanic activity observed on this moon is not just a sporadic event, it's a persistent, ongoing phenomenon. From the surface, scientists have detected constant emissions of heat, volcanic gases, and ash clouds. This ongoing activity indicates that the moon's geological processes are extremely dynamic, with the landscape continuously reshaped by eruptions. The eruptions likely create rivers of molten rock and vast plains of solidified lava, contributing to an ever-changing surface. In other words, this is not a stable, quiet moon, but a world constantly in motion, as fiery eruptions send plumes of gases and debris into space, only to be replaced by new volcanic features. How did scientists make this groundbreaking discovery? The key lies in the advanced tools used to study distant celestial bodies. Telescopes like the James Webb Space Telescope and other high-powered observatories have enabled astronomers to examine the distant exomoon in ways that were once impossible. Using these instruments, they detected unusual heat emissions coming from the moon's surface. These heat signatures were far higher than what one would expect from a moon that might be cooling or stable. Additionally, the detection of gases such as sulfur dioxide and various other volcanic compounds suggested that the heat was not from some passive source but from active, ongoing volcanic processes. The emission patterns, along with unusual atmospheric compositions, further suggested that the moon was experiencing regular volcanic eruptions. The evidence pointed toward a world constantly reshaped by its violent geological activity. But why is this discovery so important, and why are astronomers so excited about it? For centuries, scientists have focused much of their search for life on planets within the habitable zone, the region around a star where liquid water could potentially exist. Planets in this zone were considered the best candidates for harboring life, as water is one of the essential ingredients for life as we know it. However, the discovery of this volcanic exomoon challenges our previous assumptions and broadens the scope of where we might find life beyond Earth. The concept that volcanic activity could play a role in creating habitable conditions is not new, but this discovery marks the first time we've seen such a process occurring so far from Earth. On Earth, volcanic activity is believed to have been a driving force in the early development of our planet's atmosphere. Volcanic eruptions release gases such as carbon dioxide, methane, and water vapor, key components of a planet's atmosphere. For many years, scientists have speculated that such processes might also occur on distant planets and moons, creating environments where life-supporting elements could be produced. The presence of volcanic activity on this exomoon provides crucial evidence that similar processes could occur on other moons and planets, making them more likely candidates for supporting life. In fact, some researchers speculate that the heat and energy generated by volcanic eruptions could create the ideal environment for microbial life to thrive in the subsurface of such moons, much like the conditions believed to exist beneath the icy crust of moons like Europa and Enceladus in our solar system. Moreover, the discovery raises the possibility that volcanic moons may play a key role in shaping the evolution of moons and planets in other star systems. Just as Earth's volcanic history helped shape its atmosphere and possibly catalyzed the development of life, volcanic moons around gas giants could have their own unique evolutionary trajectories. Some scientists believe that the active geological processes on such moons could help create a stable, long-term climate by cycling gases into the atmosphere and possibly even contributing to the formation of oceans or lakes. If these moons are warm enough, thanks to their internal heat, they could even support environments similar to those thought to exist on early Earth, where life might have taken root. This discovery opens up a wealth of new possibilities in the search for life beyond Earth. While exoplanets have been the primary focus of the search for habitable environments, exomoons, especially volcanic ones, are beginning to emerge as key players in this search. Gas giants, like the one hosting this volcanic moon, are incredibly common throughout the universe, and many of them are believed to have moons. If just a fraction of these moons are volcanically active, like the one discovered, the number of potential sites where life could exist in some form multiplies significantly. These moons might not only provide the right chemical building blocks for life but could also harbor the necessary heat and energy for life to begin or even thrive. As our understanding of these distant worlds deepens, the future of space exploration looks incredibly promising. More advanced telescopes, spacecraft, and future missions to distant exoplanets and moons will likely yield even more discoveries of volcanic moons and other extreme environments. With the technology available today and in the years to come, scientists will continue to study the conditions on this volcanic exomoon, looking for further signs of habitability or even possible microbial life. It's also likely that future missions, including those aimed at sending probes to gas giants and their moons, will provide more direct evidence of the violent, yet fascinating, nature of these distant worlds. The discovery of this volcanic exomoon is just the beginning. As we continue to push the boundaries of space exploration, we will encounter many more strange and surprising worlds, each with its own unique characteristics. This volcanic exomoon serves as a powerful reminder of how much we have yet to learn about the universe and the incredible diversity of environments that exist beyond our own planet. It's a reminder that life, in some form, may not be confined to Earth-like conditions and that the universe is full of dynamic, ever-changing worlds, each one offering new opportunities for discovery and understanding. As we look toward the future, one thing is certain: our search for life beyond Earth is far from over. With new technologies and discoveries on the horizon, the universe has never seemed more full of possibilities, and the path forward for space